Welcome to Everything Distributed. Today we are going to talk about a very important kind of tool in distributed system, especially in implementation. It's called RPC, Remote Procedure Call. If you remember from the content we learned from last time, we have three methods that support you to transmit different kind of data or different kind of message between servers, and RPC is one of them. That's a second category where we do this kind of service call idea. And then, the reference for today is based on two. One is a Microsoft documentation, and then the other one is a Geeks for Gigs. And even though personally I don't really like the contents inside Gits for Gits because I use user generated, and sometimes there are tons of typos or misconception. But I think that in general this is still a good starting point. But if you want to check the technical contents later, please double check with confirm with other more reliable resources. But it's still a good entry point that gives you a big picture. Okay. So before we introduce the concept for RPC, we should understand that what is a local procedure call, or what is a function or subroutine. So when you write a program, and then when you start with, you don't have any kind of function, you just have one thread that's here. But once your program becomes more and more complicated, so you want to introduce a subroutine or the concept for function, because that allows you to you don't need to write the same function again and again. You just call a function and then you pass in different kind of parameter. Then the function will does the test or solve the test for you. So idea is very simple. At here, you call a function. So you kind of transmit the control back to the subroutine. And then once it's complete, the subroutine goes here. Suppose it's a single thread kind of process. And this is also called a synchronous kind of subroutine, because here the main thread basically does nothing, just wait for the subroutine to complete. Okay. Then why do we care about this kind of the kind of way to writing program? Because it's decompose the task. One function can handles one task. And then when you read the code or when you write the code, you don't need to duplicate the same thing again and again. So you can reuse your code. And then usually it has lots of complexity. So suppose you have a function that's very complicated, then you write it once, you make sure that it's correct. Then whenever you call it, you don't really need to follow all the logic inside the function. And then if your function is well defined and then it has a good name, and usually that this kind of way of a writing program improves the readability. And one way is that if you need to debug lots of complicated program, actually that you do this a subroutine way, it also help you to maintain your code, because most of the modern program language provide a code trace. It means that it will tell you that, okay, when you execute the program, which subroutine or which function you code, and then usually that it gives you an idea where it might go wrong. Okay. Then now let's look at the web service. Suppose you are browsing something, and suppose you are searching something on Google, then in your web browser, actually it's very much like the function code. So here, like you say, okay, I enter something, I click search or I click enter, then the web browser as a client of the web service, it will send a request to the Google server, and then Google server will do some search query, and once it completes, it will send back to the web browser, and then this is the time that the web browser will show the content to you. And this, of course, web service is much more complicated in practice, but the synchronous way of doing things is one of the simplest way. So here by synchronous is that during this time, the client doesn't do anything. It just wait until the Google server tell it that hey, here's your result. Okay. Then so that's one way to implement web service, but like why do we care? So if you remember from last time, this method of a data flow is called service call. So we kind of exchange information or we exchange data between client and server. And the big idea for RPC or the big idea for remote procedure call is that this kind of remote service actually in terms of programming we can make it work like the local function. So you might think that okay, that's super easy, but it's not until it's actually that mentioned a very good paper in back in 1984, and after that time, people kind of realize that we can do this because in terms of implement this kind of stuff, it's not as trivial. So the idea is that very simple. It's just the same as the figure I showed you before. Now we have a client, usually in the terminology we can call caller. Caller will call the function just like how you call a local function, and then callee is that it has some server. It will receive a parameter you pass in and then process it. Once it's done, send a reply. It's exactly like how your local function should operate. So on high level, it's very simple. Then, but like in practice, when you implement it, actually it has several steps. So the idea is that we have this RPC stack. So first is a client function, and then the client function will tell this kind of client stop, or you can think of it as a proxy. Say, hey, I'm going to send a message. And if you remember from last time, you cannot just send arbitrary data, arbitrary message. When we send a message, actually it's a sequence of bytes. So here you need to do some encoding. And once you do encoding, you also need to figure out where the server or service is located, and then you tell the RPC library. So here RPC library does some OS like operating system stuff and networking stuff. You will send it to the other end. So this is the server side. This is a client side, and RPC library receive it. It will forward it back to the server stub. It's also called skeleton, and then it will do some decoding and then pass it to the server function. And here is the place that you are solving the test. So if we consider the Google search example, here is the where the Google server will process your query. So once you get a result, you kind of reverse it back to the stack. You send a message to the stub do some encoding, and then tell RPC library, say, hey, send a reply to the client, and you send it like typically through TPC, the TCP, and then RPC library will receive it, forward to proxy, and proxy will do decoding and back to client function. And that's how you complete the whole cycle. Okay. And so here is a summary on like what this stack is doing. First, you need to do encoding, and then you also need to handle in like how to send the message and where to send the message. And then once you receive something, actually it's RPC library, sorry, the stop act as a kind of TCP server. You need to process incoming messages, and you also need to do the decoding. And once it decodes, it will reply to the client function. So that's the summary of what the proxy is doing. And then the benefit, even though like it traverses lots of components, is that abstraction. So if you remember from the very beginning, like computer science actually is about abstraction. And then this provide you a very powerful way to do things, to write your program, because you don't care about that whether this function is remote or just local. And it provides a procedure called interface that for you to execute. And then usually it's much simpler to develop because you don't need to care about socket, you don't need to worry about port number, and then how to encoding or decoding a byte. The RPC library or the whole stack take cares that for you. But of course that there's no perfect solution. When you use RPC, especially in like kind of wide area networking, or like if your server or the machines is not very reliable, there are tons of issues. So for example, how do you pass the parameters if the file is very large. So in the machine, everything is on the disk or on the memory. Everyone can go get it. But in RPC, actually, it's not that simple. And then you also need to have this location service. Where's the server? Where should this message go? Then I suppose the server wants to send back to the client. What if it cannot reach the client? And all this kind of issue. And of course, when in the OS or networking layer, now you need to worry about what kind of transport or how do you send a message to other? Are you going to use UDP or are you going to use TCP? And then the biggest issue is how to handle errors. So in in your local code, maybe you throw an exception or you have some panic code, but for the server, actually that is not clear how can you handle the failure so that the client can take a proper action. Okay. But even though there are tons of issues, RPC is still a very nice framework for you to kind of call the remote service. And yeah, there are many different popular RPC framework that's used widely in industries. So the first one, Aero, and then also the Google one, gRPC, and then the Apache one, Thrive. I have no experience in Aero, but both gRPC and Thrive are very easy to use. And then I think that most of the time actually improves your performance because you don't need to take care of lots of dirty stuff, and sometimes their optimization works for most of the time. Of course, if you have a very specialized applications, then you might want to write your own thing. Then the other thing is that I couldn't find any good evaluation or comparison for RPC framework. So if you are interested in some engineering project, I think that doing this kind of evaluation, how to do them extensively, how to compare those, is also a very nice side project. Okay, that's all I want to talk about today. We discussed RPC, what's the benefit, what's the disadvantage, what are the key important components, and so in practice is that okay, you know this stuff, but then the next thing to ask yourself is that do I need this? Then you want to consider the benefit and then potential issues, and okay, that's it. Thank you.